All right, so now we have arrived here at a problem where we can apply our skills in taking antiderivative or the indefinite integral into doing a problem in business field. Okay, so let's spend some time reading this problem right here, the wording description of this problem. So a certain company has sales of some kind of DIY cleaner. If the company has X sales, so X here is the number of units being sold right there. So if the company has X sales of the DIY cleaner, then the marginal revenue of DIY cleaner is, so we're looking at marginal revenue, and the function is being highlighted here. Okay, and so MR, or the same as R prime of X, is 6 times e to the 0.01x. Now, if the company has no sales of DIY cleaner, then the company has no revenue. Now, what is the revenue from having X equals 105 in sales? So, this is how I see about this problem. The expression 6 e to the 0.01x is clearly marginal revenue, and that's so. Just like I have explained in the general lecture, for us who are doing business, a lot of time it's actually easier for us, because maybe we hire analysts to find this out for us. But a lot of times it's actually easier to notice the change, how fast our revenue is changing, and that's why we start out having this marginal revenue being given. So that's one good scenario that can happen for us right there. And so now from this marginal revenue, or yes, this is simply just this can be understood as R prime of X, the derivative of our revenue function. And so the question was asking us to find the following. What is the revenue from having X equals 105 in sales? So, what is the revenue? Okay, from having X equals 105 in sales. So this is what it says here. Now again, we have revenue, we have marginal revenue. We know R prime of X, but unfortunately we don't know what R of X is, and so that means we are on our way. We're on our way to find R of X. But then the actual question is asking us that once we have found R of X, then we need to find R at 105, because see, what's going to be the revenue when X equals 105? That's what the question is asking. Okay, and so we must first, from our revenue here, that's the plan, from our marginal revenue, actually, we're going to have to find the actual revenue function. Then from there, we're going to be able to successfully substitute 105 in there. Okay? So now, from our experience learning about taking antiderivative or indefinite integral, then once we have our derivative given, we can go back and find the function before derivative by taking the integral or taking the antiderivative. And so now, I'm going to take the antiderivative on that function 6 e to the 0.01x, or I call this is the indefinite integral of our function 6 e to the 0.01x. And so if anyone is viewing this video lecture here, for this particular example that I'm showing in the video here, has had a chance to view my general lecture to describe to explain about all about the antiderivatives, then I generalize the idea that see, this is e to the ax like that. Okay, that's in connection with with what I have explained in detail in my general lecture regarding antiderivatives. Then, and it's a constant coefficient, so we can do the antiderivative as following: 6 antiderivative e to the 0.01x. And then, so from that, see, this is the little special case of exponential function. And so now it's going to be 6 times 1 over 0.01 times e to the 0.01x and plus c. Okay, and so recall from my general lecture again, I have to mention, so antiderivative or indefinite integral of e to the ax is going to give you 1 over a times e to the ax plus c. That's what I introduced in my general lecture about antiderivatives and indefinite integral. So in that way, now we have come to a general antiderivative of our function here, and we can write that in a little nicer form here. So revenue here has been found. The general revenue function has been found to be 6 over 0.01, and 6 over 0.01 really in calculation in actual value it's going to be 600. So 600 e to the 0.01 x plus c. That's our general antiderivative if that was for any reason our known marginal revenue function. Okay, so this is the antiderivative of marginal revenue function. But then in order, and keep in mind that we need to find the specific revenue function so that we can successfully substitute 105 into our problem. This is our goal right here. We need to find R of 105. But in order to do that, we need to successfully find out what our constant is for this antiderivative. And so that means here, once again, in connection with the general lecture I have described, I have explained, and I also deliver an example where I introduced in a problem where I so-called the initial value problem. This problem here is going to be an initial value problem because it does require you to find that particular solution, or in other words, it wants you to find out what that particular value for the constant here before you can attempt further and find the revenue at x equals 105. So now we need to go back to the wording of the problem and identify for ourselves the initial condition. So the line that we need to pay attention to now is this line right here. If the company has no sales, then the company has no revenue. This line has a tremendous impact for our work right here in terms of or as an explanation, as a good explanation for the initial value problem here, because it says that no sales means x equals 0, and at no sales, if the company has no sales, then the company has no revenue. Okay, and so that means if when x equals to 0, then R equal to 0, or in other words, a shorter way of saying the revenue at the 0 sale equals 0. This is indeed our initial value, initial condition right here. All right, that's our initial condition. And so what's useful about that? So now in our case, revenue function has been found so far as a general antiderivative. 600 e to the 0.01 x plus c. But now according to this initial condition given, and I translated that from the wording of the problem, and that means, and so right from that equation, then we're looking at 600 times e to the 0.01 times 0, because 0 is now substituted for x. That's R of 0 over here. And plus c, and we need that to equal, according to the initial condition given here, we need that to equal 0. Okay? And so in that case right here, now 0 times 0.01 in the exponential part of our exponential function here is going to give me a 0. So e to the 0 is 1, but times 600, so all that here is going to be just 600. And you can use your calculator to verify that, and plus c, and we want that to equal 0. And so a quick little solving work here now tells us that c value must equal negative 600. Okay, and so now in that way we are ready for finalizing our final revenue function. So I'm going to navigate back to advance back to my other board right there. So this general revenue function is now no longer a general antiderivative. We now come to our final particular revenue function that's satisfying this given initial condition there. So R of x, now our revenue function is 600 e to the 0.01x minus 600. That's our, at least we have found our particular revenue function that models in this particular case right here that satisfies the given initial condition here. Okay, so now we are so ready to get into the ultimate question of our part right there. So far we've been just tracing the steps to get closer and get closer to being able to answer our question like that. But now we have made big found. Okay, R of x equals 600 times e to the 0.01x minus 600. That is our revenue function for this company according to the way how they perform like that. So now, final answer, R of 105 is now just a matter of substituting 105 into the x variable here. So 600 times e to the 0.01 times 105, and then subtract 600. Okay, so I am going to take a minute or so to step away and do a calculation. All right, so our answer now comes out. Revenue for selling 105 units, the DIY cleaners comes out to be $1,114, and of course in decimals we only need 2 decimal places, so 59 cents. All right, so that's the answer to this question right here. That is the revenue from having the sales, having a sales of a 105. Okay.